All right, welcome. So today, as usual, we're gonna try to solve some coding challenge under 40 minutes or so. Hopefully, this stream is for entertainment purposes only. And let me quickly check that everything is working just fine. Looks like that. All right. Let's see what's the problem we've got today. Problems. Big one. And right, again an easy problem. Cool. You're given an integer array of numbers consisting of n elements and an integer k. Find a continuous subarray whose length is equal to k that has the maximum average value. And return this value. Any answer is a calculation error less than 10 to the power of minus 1 degree will be accepted. All right. So it's very easy. So technically, all right, let's switch to the whiteboard. Right. So how do we compute the average of any array? Let's say we have 3, 5, 4, 1, right? How do we compute the average? We sum all of them and divide by the number of elements, which you already know, which is k. K equal to 4, right? In this case, we've got 13 divided by 4, which is 3, 1/4. So, what do we need to find? Basically, we need to find the maximum value for this sum, right? How do we do this? This is easy. We first cycle until the k. So k is guaranteed to be less or equal to n. So until the first k, we just add all of the numbers, right? Then for each consecutive element, we subtract the, whatever this is, k plus 1, right? So we subtract, we add k plus 1 and subtract first element. So if it's plus 2, we subtract second element and so forth. So very straightforward. And every time we create the new sum, we update the maximum sum. That's the idea. Finally, we return this max sum by k. That's it. So very straightforward, very simple algorithm, linear complexity, constant space complexity. So basically turning here, we need just two sums, right? And that's it. In sum equals 0 and int max sum equals sum, whatever. So while now we can do as part of one cycle, so it doesn't really matter. Int I is equal 0, I less than nums size plus plus. if I less than k, we say sum plus equal num psi. And basically the max sum too, right? Or all right, doesn't matter. So no, we need it because we need else, right? Else we say sum I, so this time I is equal to k, right? Sorry, sum minus equal to nums I, so we no, sorry, we add new element and we subtract the old element, right? And we subtract the old element. The old element is sum minus equal nums I minus k. So if I equals to k, we first time enter it here, we will add the new element and subtract the zero element, and then so forth, right? And then all we need to say is this max sum equal to max sum and sum, right? And return static cost double max sum divided by k. That's it. Minutes and the code. Submit. So the expected is -1. Interesting. And why it doesn't work? So we say sum 0, all right, and k is 1, all right, nums is 1, all right. So theoretically, we should add one element here. To the sum, right? Which makes sum -1. Of course. CPT minimum int min. All right, so it's almost like I said. Run the code. And submit. This is interesting. So we're asking to provide continuous subarray, right? And how much I passed already? Oh, it's almost the end. I would suspect this thing actually. Let's try the long first. Because I have a feeling that maybe it doesn't look like a logic violation or some corner case. It might be some overflow or something. Nope. It's a logic violation. So 90 elements and until I is less. I see. So I see just one possible error here is that the first 20, 40, 50 elements create the sum that is greater than the actual one. So we still can return to int here and here. And maybe because we, it's a lot of whatever. Practically we can say this thing is you int whatever, it just will say a few bytes. So we update max sum here, and once we finish with the initial fill out, we can say if I equals k, which can be just once, we do this. Now it should pass. No. All right, so let's remove this and just directly save, and we can update. Corner cases doesn't work for some reason. And I know the reason. The reason is that its max sum should be equal to this thing. All right, so it's actually k minus 1, right? So the reason is that one is all right. So now it should pass finally. Not the fastest solution though, although I have no idea how to speed it up. All right, so one potential thing to speed it up, just first use while. All right, and we can say, so we can have int I as usual, right? I'm not sure if it will work this way, but we can try. Less than k, and we do this. And then we say I plus plus, then the max sum is equal to actually sum, so we don't need this anymore. And then the second part of the logic. The second part of the logic, we already know that I is at least equal to k, right? So all we need to say is this. And that's it. Run the code to verify it works. It works. Submit to verify it still passes all the checks. Ouch. All right, whatever. I tried at least. What? It's even it's even slower. Oh my god. What else can I do? I can make it const. You would change anything. So this sliding window, I don't know. It's constant time to update the max sum for every element. So then the fast cycle while to just compute the sum. I don't know if we can do this faster. I doubt it. Yeah, whatever. Let's just submit a few more times to see what's the best result we can get. I think it's just the super obvious problem, and it really varies based on the distribution of the runtime spacetime where your results will be. I think I got this one. Doesn't look the right. Yeah, the rest. At least that's fine. So can we get this 172? Just wonder. Should we use 4 at all? I mean, then we just switch to while. while I list num size I plus plus yeah, I mean, it's unlikely. So 1/4 cycle actually was the fastest version. There's just 2 cycles. All right, I will stop here, I guess. I doubt I can get better scores. Unfortunately, whatever. Mm-hmm. 12 for time complexity, super crowded task, and 61 for the memory. So all together, this is 73. Oops. Yeah, kind of. What the heck had happened here? Alright. That's it for today. Thanks everyone. See you next time. Bye.